other terms. So sigma is equals to, here we are calling it as sigma, the power reflected towards the source by unit solid angle by incident power density by 4 pi, that is the reflected power by the transmitted power. So where r is the distance between radar and target, and er is the reflected field strength at radar, and ei is the strength of the incident field of the target. So here how we are going to be finding the RCS is, this is a function of frequency and wavelength, target geometry, aspect angle, material composition. So the amount of the power reflected by the target depends upon many factors such as the size of the target, shape of the target, and composition of the material of the target, edges of the target, and frequency of the incident radar signal and angle between the radar system and the target. So here according to this we are classified the radar cross section of targets into two types. One is the simple targets, other one is the complex target. Generally we are going to calculate the radar cross section. Sigma is equals to pi r1 and pi r1 r2. So now we are going to see the RCS of the simple targets. So a perfectly conducting sphere acts as a good isotropic radiator. That incident radiations is scattered uniformly into all 4 pi radians. The RCS is a function of its circumference measured in wavelength showing in the figure. So the RCS of the sphere is categorized into three regions. So first one is the relay region, that is 2 pi a by lambda less than or equal to 1. So where there is a radius is less than the wavelength. So next one is the optical region where 2 pi a by lambda is greater than 1, that is a is approximately equal to lambda. So of the target occurs in the region. My region 2 pi a by lambda is equal to 1, a is greater than lambda. So here we are plotting the graph between the circumference by wavelength to the spherical structure. So the radar cross section of a sphere, a is the radius and lambda is the wavelength. So simple targets we are dividing into three regions. One is the relay region, one is the optical region, next one is the pi region. So next simple target is, if you are having the cone and sphere shape, so we are going to get it is a cone whose base is capped with the sphere, and the cross section of the cone sphere is very low and is considered to be a ballistic missile. A large cross section occurs when a radar view the cone perpendicular to its surface. So RCS, here we are having plotted the three lines. So three graphs. One is radar cross section of plate, radar cross section of sphere, and RCS for total. So first, if you indicate the red line is a sphere and the blue line is a plate, and black line is a dotted line is of total. So degree per RCS dB. So if you are finding the radar cross section for complex targets, RCS of complex targets such as ships, aircraft, cities and terrains are complicated function of the viewing except the radar frequency. These types of target crosses section may be computed with the aid of digital computers measured experimentally. So here we are having the different formulas for different shapes. If you are considering a sphere, we are having the cross section of pi a square, and if you are considering a shape of cone, it has a lambda to the power of 4 by 16 tan to the power of 4 theta naught. So if you are considering the paraboloid, the area axial is r pi by sigma naught square. So here if you are taking the parallel parent, it is pi b naught by 4 by a square. So Ogawa axial, if you Ogawa shape, if you are taking the circular plate, if you are taking the large flat of arbitrary shape and circular cylinder. So according to the shape it was given the characteristic dimensions. So here the dimensions may be a and theta or L. So if you are considering according to the shape where it is going to be incident and how we are going to be seeing accept angle, how we are going to see that, we are going to find the characteristic dimensions. So we are having the examples of RCS and a cross section for the permanent shapes. One is the conventional winged missile. If you are considering the conventional winged missile, the constant RCS is 0.1. Similarly, we are having the small signal engine aircraft, small fighters for 4 passenger jet, large fighters, medium bombers, large bombers, jumbo jets, helicopters, small open boats, small pressure boats, cabin cruisers. So according to that, they have given the corresponding values for the constant shapes. So we are seeing the remaining example, that is ships at higher gauging, automobiles, pickup trucks, bicycle, medium bird, large insect, small insect and man. So these are the different formulas for the radar cross section starting from the large character dimensions. So these are the examples. You have to see the constant values for the corresponding shapes of the object. These are the standard targets. When we are detecting the target, these are the standard targets and we are going to get the values. And these are the remaining values. These are the standard targets. So we have estimated the value displacement token in meters per square.